So here for question 4.52, conical diffuser of initial radius r, as shown here, expand at a uniform angle theta. The flow enters at uniform velocity u naught, assuming at a one-dimensional free stream. Use any laminar boundary layer method of your choosing to estimate the angle theta for which flow separation occurs at x equal to r. So x equal to r here means that, so we have a distance at x-axis here, so the distance is around 2r. So means that previously I already share you a notes about the separation. So separation occur when you have angle or in curved surface. So for example, if you have a cylinder like this one, so at certain point the airflow here will detach from the surface. So this is the separation. So another application for this one is actually when we have a convergent and divergent nozzle. So means that if you have convergent and divergent nozzle, for example, we have a situation like this one. So and then the flow will comes in, and then suddenly the flow will detach from the curved surface here. So in this situation, so we assume that we have a conical shape like this one, and then the flow will enter this from here, and then at certain area, so the separation will occur. So and then in this question, they ask us to calculate what is the angle, okay, where the separation occurs at x equal to 2r here. Okay, so first we need to calculate the velocity. So we know that because we assume that there are no compressible effect, so mean we just use the idea of volumetric flow rate. So we have A1 V1 is equal A2 V2. So we know the cross-sectional area and velocity at inlet, which is the pi r square times u, and then we could estimate the volume flow rate at the outlet, mean at any situation here. So we just use the cross-sectional area is pi r square, pi small r square, because we assume that the r here is the variable value of radius, and the small u here is actually the u that occur at certain location of x. Means the small u means the velocity is keep changing. The capital U means the value is constant. So and then we could rearrange the value here into these terms. Small u is equal to capital U r square over r over a small r. So and then we need to, again, so in this situation, okay, I hope you could get an idea, because the nature of solution is actually same with the triangular flat plate. So in this situation, we found that the value of r here is actually dependent on the value of x. So mean if the value of x increase, so the value of r will increase, then the velocity may be decrease, something like that. So means in this situation we have two variables. So what we need to do is actually we try to substitute one of them into another variable, so we only could have one variable. So what we do is we need to create an equation, the relation between r and x. So what we could do is by having this triangle. So for example, we have this triangle. So previously in our question, the conical is actually about this shape. Okay, so and then to have equation, it is better for us to draw a triangle like this one, because we will have an origin. We have the start of 0, 0, so it might be advantage for us. So let's say we have a triangle like this one. So and then we could say that for triangle ADE, so the bigger triangle, So we have tangent theta is equal r divided by 2x here plus f. So let's say this is just distance here. So and then because we want the angle for 2x, okay, this is the condition here is used because the question asks us to find, okay, let's say it's that method because it is 2r. So let's say this is a 2x. So and then plus f, and then the tangent theta here is r here divided by f. So and then we have f is equal r over tangent theta, and then we substitute the value of f here into these terms. So and then finally we could get this one, and then we could simplify the term of r here as r 1 plus kx, and k here is actually the 2 tangent theta over r. So this is just to simplify our calculation. So and then what we use is actually, we use the Thwaites equation, because the Thwaites equation is actually to learn about the separation. If you still remember the tutorial that we conduct previously in our notes, we will use Thwaites, but on that tutorial we plot a graph to recognize the value of lambda, which is, it must be equal to negative 0.09 to determine the separation. Okay, so now because the question asks us about the separation, so we use again the value of Thwaites equation. And here we actually have two equation of Thwaites. One is for plane surface, and one is for asymmetric surface. So asymmetric means if you're dealing with something circular, in circular cross section and so on and so forth. So now we need to use the Thwaites equation for asymmetric, axis symmetric equation, because in our model, in our diagram there, we have the terms of radius r. So we use this one. So and then we substitute the value of u here, velocity. So from where we could get this u, so it's comes from the first idea here. So we substitute the terms of velocity. So we have u by the power of 6, and then we have r squared and u by the power of 5. So we substitute this one, and then we substitute the value of this term. Okay, so we have the r is equal to r, capital R 1 plus kx, which is k is actually referred to this constant. So we substitute this one, and then we solve these problems. So and how to solve this one? So I think I show in previous notes. Okay, the way we want to draw a graph. So and then we have this one, and then we calculate the du dx. So we know the value of u is here, and then we substitute the value of r with this term, and then we could have du dx is equal to this one. So why we need to do the differentiate du dx? Because we have the value of lambda here. So the value of lambda, we have du dx here. So we substitute with the terms that we have. So and then we know that the lambda is equal negative 0.09. So and then we could have the value of kx equals 0.0788. We substitute back the value of k here. So we have 2 tangent theta over r to r 0.0788. And then we could determine the value of theta here is equal to 1.13 degree. So it is mean that if we create our conical here with angle here is 1.13 degree, so means inshallah means if God will, the separation could occur at distance of what x axis here equal to 2r.